China just launched a mind-blowing energy project that's sending shockwaves to the global power industry. The Chinese government has greenlit a massive space-based solar power station that could generate more energy in a single year than all the oil ever extracted from Earth. This isn't just another solar farm. It's a technological moonshot that could rewrite the rules of energy production worldwide. While the West debates incremental changes to our power grid, China is literally reaching for the stars with a project so ambitious it's being called the Manhattan Project of Clean Energy. Buckle up. Let's break down how this cosmic power plant could revolutionize global energy and why it matters to everyone on Earth. The Stratospheric ambition. China's space energy Gambit. Energy independence has been China's strategic goal for decades, but their latest move takes this ambition to orbital heights. The newly approved space-based solar power station will be positioned in geostationary orbit, 22,000 miles above Earth's surface, where sunlight is unobstructed by weather, clouds, or the day-night cycle. This positioning allows for 24/7 power generation at an efficiency level impossible to achieve on Earth's surface. The scale of this project rivals China's massive Three Gorges Dam, currently the world's largest power station, but with potentially far greater output. Chinese scientists estimate that a fully operational space solar array could collect enough energy annually to match the total amount of oil ever extracted in human history. This quantum leap in energy production could fundamentally alter China's position in the global energy market and potentially solve their persistent energy security challenges. The celestial power plant, engineering on an unprecedented scale. The technology behind China's space solar station sounds like science fiction, but it's based on proven principles. Giant mirrors would concentrate sunlight onto high-efficiency solar panels, converting it into electricity. This power would then be transformed into microwave radiation and beamed down to receiver stations on Earth, where it would be converted back into usable electricity and fed into the power grid. The engineering challenges are staggering. The solar array would span several kilometers in space, requiring multiple rocket launches and in-orbit assembly. Chinese engineers are already testing key components, with small-scale prototypes demonstrating the feasibility of wireless power transmission from space. The microwave transmission system must be precisely calibrated to safely deliver power through the atmosphere without energy loss or environmental impact. The Manhattan Project of Energy. Overcoming cosmic challenges. The comparison to the Manhattan Project isn't hyperbole. This initiative represents a similar level of technological ambition and national commitment. Chinese officials have assembled a team of thousands of scientists and engineers across multiple disciplines, with funding rumored to exceed $50 billion over the project's lifetime. The challenges they face are formidable. First, there's a matter of launching thousands of tons of materials into space, a feat that will require dozens of heavy-lift rocket launches. Then comes the complex task of assembling massive structures in orbit, far beyond the scale of anything previously attempted. The power transmission system must navigate technical hurdles related to beam focusing, atmospheric penetration, and safety concerns. Each of these challenges represents a potential showstopper, yet China's methodical approach suggests they're prepared for the long haul. This isn't a quick win. It's a multi-decade commitment that could reshape global energy dynamics if successful. And that's exactly what has other global powers concerned. Global power shift. The geopolitical implications. China's space solar ambitions extend far beyond clean energy. They represent a strategic move to secure technological dominance in the 21st century. If successful, this project would position China as the global leader in two critical domains: renewable energy and space technology. The implications for international relations and economic competition are profound. Other nations are taking notice. Japan has accelerated its own space solar research, while the United States recently revived interest in similar concepts through DARPA and NASA initiatives. The race for space-based energy has begun, but China's head start gives it a significant advantage. Beyond competition, however, lies potential cooperation. The scale of this project may ultimately require international collaboration, creating opportunities for scientific diplomacy in an increasingly divided world. Some experts suggest that space solar power could eventually become a global utility, with multiple nations contributing to and benefiting from a network of orbital power stations. This project also represents a clear shift in the global technological center of gravity. For decades, the United States has led the most ambitious space and energy initiatives, from the Apollo program to the development of shale oil extraction. China's bold venture signals that the era of unchallenged Western technological supremacy may be ending. As emerging powers like India and Brazil watch China's progress, they too may be inspired to pursue similarly ambitious projects, further rebalancing global technological leadership. The diplomatic ripple effects could transform international organizations like the United Nations Office for Outer Space Affairs, which may need to develop new frameworks for governing energy collection and transmission in space. Questions about orbital rights, satellite interference, and microwave transmission corridors will require new international agreements, potentially reshaping space law for generations. The earth-changing potential, environmental and economic impact. If China succeeds, the environmental benefits could be extraordinary. A single space-based solar station could replace dozens of coal-fired power plants, dramatically reducing carbon emissions while providing reliable baseload power. Unlike terrestrial solar farms, space-based systems aren't limited by weather conditions or day-night cycles, offering stable power generation that could complement existing renewable sources. The economic implications are equally significant. As the technology matures and costs decrease, space-based solar power could eventually become competitive with traditional energy sources. China's first-mover advantage would position it to export this technology globally, creating a new industry potentially worth trillions. For countries lacking domestic energy resources, space-based solar energy offers a path to energy independence without the environmental costs of fossil fuels. The ripple effects would transform industries from manufacturing to transportation, potentially accelerating the global transition to electrification. Rural areas previously disconnected from power grids could receive electricity through distributed receiver stations, bringing energy access to billions currently without reliable power. This transformation would extend to every corner of the global economy. The automotive industry, already pivoting toward electric vehicles, would see accelerated adoption as clean electricity becomes more abundant and affordable. Heavy industry, including steel and cement production, sectors notoriously difficult to decarbonize, could become viable candidates for electrification with space-based power's consistency and scale. The shipping industry might finally have a pathway to zero-emission operations through electrification or synthetic fuels produced with space-based electricity. The road ahead is long and fraught with technical challenges, but China's cosmic energy Gambit represents one of the most ambitious technological projects in human history. If successful, it could reshape our relationship with energy and redefine global power dynamics for generations to come. What's your take on the space energy revolution? Do you think beaming power from space is the future of clean energy, or are there better alternatives? Drop your thoughts in the comment below, and don't forget to subscribe to the Space Grid for the latest updates on space news from around the world. Thanks for watching, and see you next time.